Hello and welcome, everyone. Welcome to DevChatter. Today is Monday, July 2nd. Hopefully everybody is having a good start to your week. I know Monday is not everybody's favorite day of the week, but today we're hoping that we can make it a little bit better because we are going to start with some coding. For those of you that don't know, my name is Brendan, and this here channel all around us here is DevChatter. And on this channel, we like to write code. We do it live, and we get a lot of audience participation. And I guess we have a really good community that likes coding and gets involved and contributes to our projects, so it's a lot of fun. Today is another one of our special streams. So this is actually our second episode of a series that we're doing here on the channel. The series is called Learn to Code in C#, and for that we are, and I apologize for opening a can, but as my regulars know, I like to drink a nice Pepsi while we watch. And what we are going to do today, as part of our Learn to Code series, is kind of building on what we did last time. So our first episode was on Saturday, so just a couple of days ago, and we did some basics, and I kind of told everybody, you don't need to know all of the reasons why we're doing everything in the first episode. So we were coding along with simple things that you could just start out with, and I said, just go ahead and ignore what we're doing, just kind of follow along and do what it is, and change the values that you can figure out that you can change. So things like changing the values of a string, changing the values of integers. And we did a little bit of user interaction in that we would send messages out to the user on the command line and accept them using a write line and a read line. Now, I didn't get into how any of that works, what any of those are, any of that kind of stuff in the first episode. I kind of said don't worry about it. But I also want to let you all know that we are going to cover that. We're going to talk about how all that stuff actually works. We were going to jump into something more interesting today. So at the end of our last episode, we built a guess a number game together. So essentially, the program would pick a random number, and actually I'm going to bring that up. Why not? I think it's still in here. We had it commented out, but this is the code that we wrote for our guess a number. And essentially all it did was pick a random number and let the user guess a number, and we would tell them whether the real number is higher or lower. Rubik's, that's awesome. And anyone else who is in here, you are welcome to watch the episode 1 video, which you can find here in the videos section. If you're on Twitch, or if this is eventually on YouTube, you'll just look for episode 1 and you can watch these in order. And if you did not catch that episode, you are still welcome to stick around and program with us. You do not need to watch that one, but it will get you some extra information, get you a little more comfortable. So this could be a big step if you didn't do that one. Okay, so I wanted to show you guys this. The programs that we need to have you install in order to follow along are, I just posted in chat. So if you do want to follow along, you'll want to install Visual Studio Code, which is what that first link is, and that's at code.visualstudio.com. The next thing you'll need to install is the .NET Core SDK, and that is what that link gets you to there. So that's microsoft.com/net/download/core, and that will get you so it's called a software development kit, and that's basically all the pieces, parts that let you build C# and .NET Core. So those are the technologies that we're actually building with. The Visual Studio Code is actually our text editor, so that's this window that you see around me here. That's all VS Code. And then the third thing that I recommend that you install before you do this is in here inside of this extensions. Once you open up VS Code, click on this little icon here. It's this one that's like this little box. This is our extensions. and you're just going to look for the C# extension. So you're just going to do C and then a number sign here, and it should come up and be probably the top one. It's going to list Microsoft being the company it's from, so it's going to be C# for Visual Studio Code and Microsoft, and this is going to help us out with the editing when we're inside of Visual Studio Code. And once you get those installed, you are ready to follow along. I'm going to try to keep going and not slow things down too much, but if you do come in a little late, there's a little bit of catch up and you can skip some of the things that we did before in the episode and just jump to that point. Okay. Okay, so there was a question from Rubik's in here. Okay, so, which is a fantastic question that we are about to cover. So yesterday, the things that we talked about, or not yesterday, 2 days ago, Saturday. I know my days of the week. We covered while loops, for loops, if statements, else statements. So we did essentially the types of things that let us sort of control the flow in our program and make decisions based on things. We also did a minor amount of input and output using read line and write line. Then the other things that we looked at were storing things in variables. So we talked a little bit about having strings of characters in a string type variable. We also had integers and integer type variables. So those are some simple type variables that we can use to store information that we use around our programs. And we also talked about string interpolation. So that was the fancy thing where we could insert our values inside of the string, and that sort of let us do that. And I think those are the main topics that we covered in the last one. Today, as Rubik's asked what topics we're going to be covering today, I want to introduce you all to functions, which are going to be, and I'm going to use a big word here, it's encapsulated behavior. So essentially the idea is if you want to do the same behavior multiple times from different places, then we're going to go ahead and put those in there. And yes, Rubik's, so one thing that I do want to actually mention to people, because we did mention functions, is that functions and methods are two words for basically the same concept. And what I want to point out to anybody here is that while those two words sometimes have a different meaning, in C# we tend to use them interchangeably. Now when I say that I'm going to show you functions today, I mean that in the sense that some languages use the word function when there is a distinction. So in C# there's not a strong distinction because technically, for anyone who does know about this, I am going to talk about static methods, which I'm going to call a function because that's about as close as we get to one in C#. So normally we would just use the same word for those. Yeah, so that is actually what the difference is. So normally a function is, so to answer your quick question there, Rubik's, outside of C#, a function is not necessarily tied to a class, whereas a method is. And so in this case, a static method is kind of closer to a function. So that's why in C# we have a local function, and it's not a local method. Yet, not exactly, James, but it's closer. So a function that was not actually tied to a class at all and was just on its own is more what it would be. So that's why a static's a little closer, because it doesn't require an instance of the type. And I apologize to anybody that was confusing for. Don't worry about what I just said if you're new to programming. You don't need to understand all the things. Okay. And that's actually something that I would say even to any experienced programmers that are here. You don't need to understand all the things. Just try to understand as much as you can. No developer actually knows all the things. So don't let imposter syndrome get you. Okay, so hopefully that gave enough time for anybody that was showing up new to go ahead and get some stuff installed. And we are going to go ahead and get started. So I had opened up this project, but this is not the one I want. I'm going to open up another folder. So what I'm going to do is I'm going to go up to the File menu here, and I'm going to say Close Folder, and then that'll close the folder. So now I want my editor, Visual Studio Code, to open up a new folder. So I'm going to go Open Folder, and then from here I'm going to choose this new one I made. So yesterday, or 2 days ago, I was in June 30th folder. Now I made one for July 2nd. So this is just how I'm telling these apart. And welcome anyone who is lurking around in the Visual Studio Twitch chat. You now get to hear my wonderful voice talking to you. So that ought to make your day. Okay, so Aaron and Cincy, you spend too much time trying to learn all the things and not enough time actually writing code. Exactly, Aaron. And that's actually one of the focuses we do here on DevChatter is we try to just write code. So for anything that I'm ever working on here, feel free to open up the same project or another one, have Visual Studio running, and either be working on the same stuff I am or something else. So you can follow along if you like, as long as you make sure you discard your changes. Or what you can do is you can be working on something else in the same project I'm in, if you like. So I do sometimes get pull requests from people while we're live. Okay, so I have just opened up a new folder, so you don't see much here. So you'll see that I can expand this down and there's nothing. We want to add some files here. So what I'm going to do is I'm going to toggle the terminal, so you'll see it says control and backtick. I told you all that before. You can do that. Alternately, you can find it under View and say Integrated Terminal, and that will open it as well. So either way, but that'll get you to your terminal here. And then once we're at the command line, if you're new, go ahead and type the word .NET just to confirm that you got everything installed. If you did, this should come up. That means you have .NET Core installed. If you see that, you should be able to say .NET and then -- info, which it's suggesting right here is one of the options that you could pass in. So usage .NET followed by options. So that's what we're going to do. And when I do that, it comes back with a whole bunch of stuff that I've got installed. You should see the same, you should see a lot fewer choices than I have here, but it should still come back with some things that you have installed. You should see the SDK that you installed listed there. Okay, so assuming all that works, what we want to do is this. We want to say .NET new, and then I'm actually going to show you what happens if I leave off the argument. So if I say .NET new, it comes back and it says, well, I didn't know what to do. So it provides me with more information, so it's kind of helpful. So if I take a look at the terminal, you'll see it says usage, new, and then again it says I need options. And so it says I have these templates available, and I want to make a console application. So that basically means that we're going to run it here in the terminal, and that's a good place for a lot of learning of development and things like that. So we're going to do a console. So this is the short name. So what I'm going to do is I'm going to say .NET new console. And then once I type that in, it's actually going to go and create the files that I need in order to have a console application. Someone from the country that should not be named is watching the stream. I have no idea what you're talking about. But anyway, whoever is here, welcome. Hopefully people are enjoying the stream. No idea. Anyway. Okay, so I am going to go ahead and say .NET, and then I'm going to type build. And build here is actually what's going to take our code, so the text that we have in here, and I'll show you what it created for us to begin with. It gave us this program. It's a really simple one. And there's some basic structure here that I will explain eventually, but for now, just kind of go with it. We'll let it add these. So I clicked yes on that. It's going to add a couple of things that are going to allow us to debug, although I don't think we're going to do that today. But now I'm going to say .NET, and then I want to say run instead of build. Now when I do build, it takes all this code that we see up on the screen and it turns that into computer language. So it's going to turn that into a special language that only the computer understands. And then once we do that, we're going to do our .NET run, and it's actually going to run the code. So all this program does is print out to the screen, hello world. So that's what this does. We covered that yesterday. So let's go ahead and do a couple of other things. I want to take a little bit more of what we did yesterday and keep going with that. So here's what I want to do. For now, I'm going to type the word for. I'm going to cursor down one time, and you'll notice that this one says it's a for loop for C#. That's the one I want, so I'm going to hit the tab key, and that will go ahead and auto-complete this. I'm going to leave this as the letter I. Whoop! And then I'm going to step over here, and we're going to change this length. For now, I'm going to hard code it to 100. So, as you'll remember from last time, this is a loop that is controlled by an iterator variable. That's this I. That's why we... and then what's going to happen is, each time we go through this loop, I is going to increase its value by 1, and will continue in the loop until I is less than 100. Aaron and Cincy, most of this is going to be beginner stuff, but we're actually going to do something a little clever. So, funny enough, anybody who actually knows me is actually going to know exactly what program I'm going to have you all write today. We are going to write a little program. I said we're going to do a little bit of math. We're going to learn about functions. And yeah, Aaron, this is primarily a beginner one, but there are some fun things we're still going to cover. And then what we're actually going to do is... we're going to write a program that is going to find all prime numbers less than a certain number. Now, that operation in itself is pretty easy, but if you are a more experienced programmer, my challenge for you is this. I would recommend that you go ahead and try to write code along with us, and try and do this as efficiently as you can. So do the fewest amount of comparisons of values as you can. So that's what we're going to be making. So I have this loop. It's going to loop through 100 times. I mentioned before that we can start it wherever we want. So I'm going to start it at 2. And I want to do a console write line. And when I do this inside the for loop here. So that means that this is going to print all the numbers from 2 to 100. So if I go ahead and do this, this is going to like fill the screen with, yeah, see? So you don't even see all the choices that were in there, but it works. So that's cool. Now we've always used console write line, so I had you doing that every time. Let's change that. Now let's change it to do a console write and do it. So this is going to be messed up first, and I'm hitting save before I go down to run. Now, when I do a .NET run on this, you're going to see all the numbers are just shoved together. So that's not what we want. We want commas between them. So what we can do to get that is this. We could either do another line where on this line we print out a comma. So we write a comma each time. So this would work. And when we run this, you'll see there are commas between them. Or, alternately, we could put it in the other one. Console write, what do you want me to have in there, Wheelspin? You're suggesting we put in this? That's not quite right. Oh, okay. So anyway, we could take this approach, and it works just fine. So we'll leave this in here. Now, here's the challenge. We have a trailing comma. I'm not going to worry about that just yet, but we'll talk about how we can do that. So, for now, we're printing out these numbers. So, if I told you now that I wanted to only print out prime numbers, not every number, well, first off, you'd need to know the definition of a prime number. So, what we're going to do is we're going to discuss that. So, anybody here know what the definition of a prime number is? Yeah, Blue Spied, we could do a join. That is absolutely right. But a definition of a prime number, since no one has jumped in with it, is any number that is divisible by exactly 2 other numbers. So, essentially, it's divisible only by exactly 2 numbers. So that is 1 and itself. Now the reason I phrase it the way that I did is the number 2 is divisible by 2, so itself, as well as 1. But the number 1 is only divisible by itself. because 1 and itself is not two numbers, that's only 1. So 1 only has one divisor. So the first prime number is 2, the second one 3, and 5, and 7. And yeah, so people are putting in the prime numbers there in the chat. And we're going to make our program do that. So what we want to do is this. We want to figure out if something is a prime number. So this is where I want to talk to you about the concept of a method or a function, because we're going to write our code a little bit nicer. So right now we're printing out all numbers from 2 to 100 in this list. The easiest way to make this work is if we could write something like this. If we could write it out, whoops, let me do this. If our number is prime, so if we could say like is prime I, and then put this code in here, because we saw this yesterday, that you can put code inside of an if statement like this. If we could do that, that would actually work really well here, because you could just read this code and say, for the numbers from 2 to 100, if the number is prime, so if is prime I, so if I is prime, then we want to print it out to the screen. And if we don't do that, then just move on. And that actually sounds like it'll work really well. So all we would have to do is write this. So this is actually what's called a function or a method, is this code. Exactly, Wheelspin. Now, how do you figure this out? So we've actually had you working with methods and functions this whole time, you just didn't realize it. So if you look at line 7 here, static void main string, and then this, and then args, that's a function. The other function, so this is, your code was actually inside of this method the whole time, but then you were also calling one here. So console.write, that's actually a function. So you've been using them from the start. We just didn't tell you what they were. So let's go ahead and make one. So what I want you to do is this. So go to the curly brace that lines up with the main one, and when you put your cursor right after a curly brace, notice that it marks the paired one. So this one and this one both kind of get a little visual indicator around them, and this one and that one line up. So they give you a little bit of help inside the editor to show you what the lined up ones are. So go after this one. So our method is going to be a sibling of the main method. So they're both inside of this class program block. So what you do is we want to write private static. Now type the word bool, and I'll tell you what that is in a second. That's B-O-O-L. And then once you've got that, write is prime. And you'll notice it's auto-completing it for me. See how it can tell? It's suggesting is prime for the name. And that's actually because it knows that I'm using that as if it were already existing. So Wheelspin is asking what private static means. Now, I don't want to jump into these right now because we're right at the beginning of methods, but this essentially means that this is not very accessible, so this is only allowed to be accessed inside of this class. And then the static means that you don't have to have an instance of that class. So that'll make some sense to some people. Okay, so what I want to do right now is return true. So just type that in for now and don't worry about anything other than that. Does this... Hang on. Why is that complaining? Oh, because I didn't do this. I'll say I for now, and we're going to fix the names later. Okay. So write this code. Make sure that you have private static bool, and then is prime, and then inside of your parentheses, type int I. So this is a variable declaration like we've seen before. So this creates a variable named I. And then here, the return true says that what we want to do is we want the result of calling this method to be receiving the value true. Now true, as you'll recall, is the default option inside of our if statement. So see that? So as long as that value is true, we'll go ahead and do that. So that's actually what our isPrime method is going to do right now, is always return true. So that means we're always going to say it's prime. So every number is prime right now. Let's see. So namespace.isPrime won't be available. James, it's actually going to be program.isPrime is what we're actually ending up with. Yeah, it's class.isPrime, not namespace.isPrime. Yep, so can the int I in the method be anything? So could I call it number, for example? Yes, and actually we're going to fix that, Rubik, so it's not going to be called I, don't worry. So when I do this, I'm going to run the program, and I want to see what we get back as the result of this. And it should be everything, and it is. So there we go. So we got back all of our numbers. So we said everything was prime. So no matter what number you gave us, we said, yep, that's prime. So one other thing that I want to do here. Now here is the fancy part. I just put my cursor on the I character here, and notice I just popped up this window. Now the way that I did this is I hit the F2 key. So function 2, if you don't have function keys, there are other ways of doing this as well. You should be able to just right-click on the I and go to rename symbol, and then that should do the same thing. And I want to call this, let's call this potential prime. So that gets a little bit longer, but that does an interesting trick that I want to point out to all of you. So inside of our for loop, in the past you always saw the variable as the letter I. That's not a requirement in the language. I is just a default that everybody knows when they see that, oh yeah, that's just an iterator variable. And usually when someone uses I, that means that the value wasn't important. So whenever you see a single letter variable in a program, it usually means it's not very important. But these ones are important, and the reason why is this. We are checking this value to see if it is a prime number. So clearly this is part of our program, which means that this is a potential prime. So we're basically saying now, if potential prime is prime, then write it. And if it's not, then don't. So that's like saying that this might be a prime. So that's what we're checking. So down here, we can do the same thing. And we can say potential prime. So we can use the same variable. Okay, so inside of our method now, we have a static method, and actually we made some changes. So let's run the code again. I recommend whenever you're writing a program, run your code, check your code all the time. That way if we made a mistake, you can fix the mistake immediately, because we know where we made our change. So just try to get in the habit of just running the code. So if you're following along, just run the code. Even if I didn't run the code yet, just try it. If it throws an exception, no big deal. You'll fix it and run it again in a minute. So that's what makes building with code so nice, is that there's low cost to just retrying everything. Yeah, exactly. Rubik's is totally right. You should try building everything and then just try to run it at the end. That'll work well. I think he was kidding. Okay, so right now we're saying that everything is prime. So here's what I want to do. Can anybody think of a way that we can tell if a number is not prime? Any suggestions for how we can do that? Anybody in the audience? And no, you don't have to talk if you don't want to. You can stay a silent viewer. But if anybody's got an idea. James says hard-code it. Okay. So we'll go ahead and try that. Yeah, no, Sky Hoshi, we're not doing test-driven development in this. This is very, very early. We'll talk about that later. Okay, so we'll say if potential prime is not equal to if potential prime equals 2. Actually, if it's not equal to, then return false, right? Because 2 is a prime. So this was the suggestion that James had, as we hard code it. So we'll put in this one, we'll run it, we print out the number 2. So cool. We could do that. We could also say, so it wasn't 2. and we'd say and potential prime does not equal 3. So as we start to do this, you can quickly figure out that this is not going to be the best way to go. So what else can we do? So we said in our definition that the way you tell if a number is prime is that it has exactly 2 divisors. That's 1 and itself. Now what do all numbers have in common regarding divisors? Well, this is a simple math thing, and remember, programming is not all about math, but sometimes we do it. Okay, Rubik's, you actually just said the key. All numbers are divisible by 1, so we don't need to check that. So what we need to check is that our numbers only have 1 divisor that's not 1, and that's going to be themselves. So let's do that. Let's go ahead and check. We'll start off simple. So we're going to say that even numbers are not prime, except for 2. So let's go ahead and do this. So if the number equals 2, and I'm actually just going to say this for now, we're going to say potential prime equals 2, then we're going to return true. So I'm going to write this backwards from before. Alternately, if potential prime, and now's where we're going to do some math. I want to say, and I'm going to explain this, but go ahead and write this code for now. Whoops. So I want to say if potential prime %2 equals 0, then return false. So this code right here is the magic code that does the work. %2, so the percent sign, what that does in C# is that's called a modulus operator. And all that modulus means is it takes potential prime, divides the number 2 into it, and it gets us the remainder. So this gets us the remainder of potential prime divided by 2. So in this case, if it's an even number, the remainder is 0 because 2 divided it evenly. If it's an odd number, then the remainder is going to be 1. So we just want to make sure that there's no remainder. And that's all this does. So that's called the modulus operator. And wheel spin, no, if the remainder is 0, that means it is not prime. So if you ever get remainder 0, it means it's not prime. That's why we return false on those ones. So, okay, so let's try running this now and see what we get. And this will confirm. Remember, we might mess up the logic. That's why we're running it. So when I look at this, these numbers are kind of small on your screen, but you'll notice that we only have odd numbers, and the first number is 2. So if I left this code out, so we're going to comment that out real fast and run it again, and you'll see that 2 is not included in the list. So we had to have that at the beginning, because 2 obviously is divisible by 2. Clearly. But that didn't matter in that case. Okay, so even numbers are out. Any other numbers that we can remove that anybody can think of? Oh, yeah. You just said or mod 3. That's a good point. Let's mod 3. So let's do this. So we're going to copy this, paste it, and we'll do mod 3. Now when I do that, I need to say or potential prime equals 3. Because watch what's going to... Well, I'll leave this off for now, but you'll see what's going to happen. So I'm going to do the same trick here and run this. And then it does 2, 5, 7. Oh, I missed 3. So that's why we have to... Whoops. We have to put that in there. So we say potential prime equals 2 or potential prime equals 3. Now I just did a thing here that I need to make sure I point out to all of you. This symbol here, this is actually 2, we call them pipes. They're vertical bars. It is actually, at least on my keyboard, on the same key as the backslash. So right above the enter key and right below the backspace is where that key is. So yeah, what Wheelspin typed in there. These are the 2 keys on the same spot on your keyboard. Are these 2? So you should see those, and one uses the shift, but this is the vertical bar. So 2 of those, and that means OR. So if this is true or this is true, we're going to do this. We do not have / keys in Korea. Oh, well, sorry, James, do you know where the vertical bar is, the pipe? Oh, awesome, Wheelspin. If you did find a bug, feel free to fix it. We are going to be getting back to that sometime soon, so don't worry. Okay, so now when we run this, we should actually see 2, 3, 5, 7, 11. There we go. And then we get to 13, 17, and then 23, and then 25. Now what's weird here is that 25 is now showing up. So 25 shouldn't be there. Neither should 35. Neither should 55. So we have all these numbers that are divisible by 5 that are not showing up here, that are in the list. So clearly that's still a problem. So there's a way that we can do this. So someone here probably notices that we could use a loop. So we're doing this one at a time, and we're just hard coding them in here. So let's simplify to a loop real fast. So what I want to do is this. I need to make a for loop, and I want to get creative on it. So let's start with a for loop. So for, again, move your cursor to the one that says it's for C#, and then hit tab. Now I want to call this divisor, because we talked about how we were trying to divide into it and using the remainder. So we're going to use a divisor variable here, and we want to go up until we get to the potential prime. Now remember that we said divisor less than potential prime, so that means we're not going to try to divide by our potential prime, because every number is divisible by 1 in itself. The difference with the primes is that the difference with the non-primes is that they're divisible by something else. Wheelspin, there are actually a lot of computers finding prime numbers. That's actually a very important thing. We actually use them within for various things in computing, so they are actually useful. Okay, so the reason I said divisor is less than the potential prime. The reason I did that, and now we're always thinking, always logic your way into this. So we're saying, how high up do we want to go in our for loop? And the thought is potential prime, because no number is ever divisible by a number larger than itself. So your largest divisor is always yourself. A bigger number clearly doesn't fit into you, it's bigger. So we're going with that to begin with. There's actually other changes we could make, but this is the simple one. So we're going to start here. Okay. The next thing that we want to do is we want to say if, and always choose the C# one, if potential prime, and then I want to use that %sign, the modulus operator again, essentially divided by its divisor equals 0, then once we do that, then we could say return false. So if we ever get to the point where we find a divisor that's not 1 or itself, we know it's not prime. So what we're going to do is we're going to kick that thing out, we're going to return, and that's what this does. So this is basically when you call a function, when it returns is when the function ends. So that's why we're getting to this. So this is our way of saying, hey, yeah, give this value. Okay, so now that we've done that, hopefully someone has noticed the problem. I'm going to get rid of this code that we were using before because it was too simple, and we want to go with something that'll last a little better. So the first thing that I'm hoping someone noticed, but no one's chimed in with yet, we have a 0 here. Well, we don't want to divide by 0, so this will divide by 0. Let me show you, actually. So we're going to run this, and the program's going to crash. There we go. Divide by 0 exception. So the cool thing when you're programming is when you do make a mistake, a lot of times it's pretty good about telling you what you messed up. Yes, we absolutely have a ternary operator in C#. So the next thing that I want to do, I'm going to change that to 1. Now this still won't work, but we're going to see a different set of numbers, and this is going to lead us further to it. So we avoid our divide by 0 exception. We're going to do this. And wait a minute, no prime numbers we come back with. Now the reason we didn't get any prime numbers is because we still don't have this right. So what we did, if we thought about this program, is the first time through this loop, this number is 2. We come in here with 2 and we say 2 divided by 1 goes in evenly. So we return false. And then we come back in here with 3. 3 divided by 1 comes back evenly. So yes, every number is divisible by 1, so we don't want to do this. So we're going to change this all the way up to 2. So this is the first one we have to actually divide by to check. So when we change that to 2 and run this, now we should actually get back the results we want. So 2, 3, 5, 7, 11, 13, 17, 19. Yep, that looks like the set of prime numbers right there. I think that's all of them, up to 100. And hello, welcome everybody. Feel free to, if you are new here, feel free to follow along. Go ahead and write the code that you want. We have instructions, so I just posted in the chat what you need to install. If you want to follow along, you can install Visual Studio Code, you can install the .NET Core SDK, and you are welcome to follow along the whole time. We're going to keep things simple. If you have questions, just shout them out, and I will answer those questions if I can. And if it's relevant enough. So simple things like the question about a ternary operator. Yes, we absolutely have a ternary operator in C#, but that's I can show you how to use that one, but that's probably not going to get used today. So yeah, Rubik's, if you already have Visual Studio, you can follow along using Visual Studio. No one has to use VS Code if they don't want to, but VS Code is a lot easier for someone to just install because it's a smaller, lighter weight program, so if you're not already a developer, installing VS Code is a much easier step to start off with. So our code works. Our program now gets us prime numbers up to 100. So let me go ahead and do the next step. I'm going to change it to 1,000 and run the code. And boom, it comes back with 1,000, so that's really cool. So if you're following along, right now, you can just go ahead and imagine that you could just go crazy with this, right? And you could just add on zeros all day long, and it's just going to get you back prime numbers, right? And you can just add those in and like, wow, look at it go. Look at that. Look at that. And those are going to be prime numbers. So that's the cool thing, is that this just works. Now, what a bunch of people here probably are noticing is that this has actually taken a long time to complete. Yeah, Rubik's. Yeah, eventually my computer is not going to be able to handle this. And actually, even this speed, you'll notice how slowly it's going. You can actually almost see the numbers counting up as it goes. So this is not very fast. So one thing I want to point out to you is that in programming, there's a lot of times that you can get the code right. But not actually... So you can get the code working, but not have it in the way that you want. So when you change how a program works without changing the actual resulting behavior, that's something we programmers call refactoring. And we're going to refactor this. Now, this is going to keep running for a little bit because it's not quite there yet. What I want to do is I want to hold the Control key and hit the C key, so kind of like copying in copy-paste command. But when I do that inside of a console window, inside a terminal window, doing the Control-C command will actually end my program. So if you end up with your program running away or it's running too long and you want to stop it before it's finished, just hold Control and hit C. So think of it like cancel. So you want to cancel the program. Okay. Yes, and wheel spin is correct. Printing the numbers the way we do also slows it down. But our code is not all that great. You are correct, actually. Keep waiting. Apparently I didn't fully get that program stopped. It still wants to print out numbers, I think. That was a runaway code right there. Burp, burp, burp. Let's go ahead and try to close it then. So I will go ahead and open Visual Studio Code. Oh, there we go. Reopen the window, please. So Visual Studio Code, the way it works is the window inside of code is actually what has all of the program and everything like that. So, yeah. So what happens is, when I do a reload, it actually just reloads the window. So you'll notice that the full outer section of VS Code didn't close. So, yes. Yes, if the channel goes offline, my computer's probably on fire. Okay, so let's go ahead and do a .NET run again. So I'm going to open up the program. I'm going to reduce this number. We're just going to do a .NET run to just confirm that everything's still working. So remember what I told you. Always just run your code. Just run it. It makes everything easier. The best tip I can give to any beginner programmer, run your code. Run your code more. And that's why anybody who knows what unit testing is, that's basically what unit testing is. It's run your code all the time. Yes, that is absolutely correct. That is a great suggestion. Salarunk? That is perfect. Wonderful suggestion. We're going to do exactly that. So, what was just suggested is that we only go in this inner loop, in our isPrime method. The suggestion is only go up until half of our number. So, let's do this. So, divisor. Now, I'm going to make a recommendation here. I'm going to put parentheses around this number. So, if you remember from your math classes, you could wrap things inside of parentheses, and that helped you control order of operations, because you do all the operations inside of the parentheses before anything outside of it. So we're doing this just to be clear. Once we do that, I want to say divided by 2. So we're going to say potential prime divided by 2. Now, because we're changing the code, we're refactoring, we might create a bug. So I'm going to simplify and change our value that we go up to be 100. That's going to make it so we can read this a little easier. So let's go ahead and .NET run again. So 2, 3, 4, 5, 7, 11, that looks right. So I think that was safe. So that's a really good suggestion. So thank you for that. Now there's an interesting, so can anyone think of any other ways that we can improve this code? There are a lot of other ways that we can improve this code, a lot of things that we can do to make this simpler. And yes, for anyone who doesn't know, I do know this problem really well. And buy a better GPU. Yes, I could actually just, have a better computer. And welcome, thank you for following. Use a function inside of a function. Actually, I think it would technically be faster if I didn't have it inside the function, but that's going to be a minor change. We'll notice more from other things. So already this should be a little bit faster than what we were doing before, because we're doing a lot less checks. Funny thing about code is that when they say simpler, they mean more complicated. Not always, Wheelspin. Recursion wouldn't be best suited for this problem, would it? No. Recursion's not actually suited to this one. Okay, so here's what I want to do. So he said divide by... Oh, yeah, you know it. Yep. Okay, so he said divide by 2. He or she. I don't actually know on Salarun. But we said potential prime divided by 2. But by that same token, we could divide by 3 sometimes, and we could divide by 4. So if we think about numbers, so whenever you're programming, what people don't realize is that programmers actually learn about all the domains they're programming in. So if I work for an industry, I know a lot about that industry because I have to write my code for it. So if I know someone that works for a sanitation company, he knows all about it. I know someone that works for the trucking industry, and he knows all about the trucking industry. Why? Because he works on their systems, so he knows how they work. If you work in manufacturing on their programs, you know how manufacturing works. Because you have to learn the industry that you're working in. So in this case, we want to... what we want to do is we want to understand prime numbers a little better, and that actually helps us do this. So let's talk about potential divisors. So, as and I really need, so I'm going to guess Minixoric. You've been here a bunch of times, but I still don't know if that's how you pronounce the name. But as he suggested, square root is the way that you can do this. So if we think about numbers, I'm going to bring one thing up onto the screen and talk about it real fast. I want to talk about the potential divisors of a number. So yes, I'm actually going to open up Notepad. Congratulations, everybody. We're all real programmers now. We have Notepad open on the screen. Okay, so if we talk about the number 100, can anybody tell me what the divisors are for 100? If anybody knows what they are and is in chat, go ahead and chime them out. But I'm going to put in a few. So I know that 1 is one of the divisors, and I know that 100 is another one. Any others that people want to chime in with? There's also, so 50, 25, 20. Okay, so we have 2 and 50. We have 4 and 25, right? And then, 5 and 20. So Rubik's gave us 1, 2, 4, 5, and then 10, right? 10 and 10, right? So then 1 times 100, so these are the results of the divisions that I put on the other side. So then we would get to 20 and 5, 25 and 4, and then 50 and 2, and 100 and 1, right? So this is all of our options. So you'll notice that the first few and the last few are the same, just reversed. So these ones are the same ones as up there. So I'm going to remove those. So when we do those divisions, we end up with those ones. So these are all the possibilities. It's when we divide 100 by these, we get these results on the right. So now the interesting thing is that means the only divisors we actually care about here are the ones on the left. So 1, 2, 4, 5, and 10. Now, the thing that Minixoric brought up was square root. You'll notice the significant thing about the largest number. Now, I could do this with anything, right? I could do it with 25, for example. 25 is going to have 1 and 25. It's going to have 5 and 5. And you'll notice again, we stop at the square root. Every time. You always stop at the square root. That's just how that works. So what that means, and hello, welcome. For anyone who is just showing up, if you want to follow along, go ahead and install Visual Studio Code, the .NET Core SDK, and you can follow along with us if you like. And if you have a question, feel free to just ask it in chat, and if I don't get to it, someone else in chat will potentially answer as well. So those are our potential divisors. So they always go up to the square root. So that is one cool little effect that I want to talk about. So because of that, the suggestion is that instead of doing potential prime divided by 2 as our upper limit, we're going to do, we're only going to go up to the square root. So there is a special thing that we can say math.square root and potential prime. Now remember, I kind of told you all the secret here at the beginning of this, and that was that this is a method. This console.writeLine, that's a method. So it's a function, it's encapsulated behavior that we want to use. So again, the same trick works here with math.square root. So that's a special function that we have that will get us the square root of a number. And welcome everybody from the C# Fritz stream. If you were lurking around, we're doing some beginner level programming here and talking about how all of our code works in C# and .NET Core. Okay, so the question from Ladal. I'm starting to learn Python, but I don't want to learn only Python. Should I learn 2 languages at the same time, or just learn Python at a good level and then move to the next? So Ladal, there. Did I say level? I don't think I did, but maybe I did. So it really depends on you. So my suggestion to anybody would be, if you aren't great at focusing on multiple things, learn one language and then learn the other. But you don't need to get to a master level before you start learning that second language. So most good programmers know a lot of languages. They don't know all of them really well. So, and it also depends on how recently they've used them. So there are plenty of programmers that will use Java for a number of years, and then they'll use, C# for a number of years. And once they start using C# for a while, they're not as good at Java as they were before. Now, if they go back to it, it'll take a little while, but they'll get back into it. So with all things, it's just how recently were you using it a lot. So if you want to learn multiple languages right off the bat, that's okay. Just try not to get them confused. So if you're good at maintaining focus, then yeah, you could learn 2 languages at the same time, and it wouldn't be a huge deal. I would recommend if you're going to do that, though, make sure that they're not too similar. So I wouldn't try learning C# and Java at the same time, like at the exact same time, because they're very similar, and you might mix them up a little bit. Wheelspin, there are a lot of languages that do derive from C. So C# obviously is one of them, as is C++ and Java. So they all derive from C, so they'll feel very similar if you know that. Okay, so the code we just wrote, looking back at this, we have a for loop that goes from 2 up until we get to the square root of our number, and then we're incrementing by 1 each time. So we talked about all this in our previous. Now there is a bug in this code that you're all going to see in a moment when we run this, and hopefully you'll spot the bug and then we'll fix it quickly. So let's go ahead and run the program. No problem, Wheelspin. And if you put the word lurk in front of that, then you can actually write whatever text you want after the lurk, and that'll still work. Okay, so anybody notice that our line is a little bit longer than the previous one, so this clearly changed. Those are not the same thing. What numbers did we add that are not supposed to be in here? That'll help us figure out what our bug is. So if I scan through this list, the first time I notice that there's a change is right about here. There's the first change. I see 9, I see 25, I see 49 that shouldn't be in here, and there might be some others, yeah. Aha, exactly. Good job, Azop. Yes, precisely. Those are the squares. So what that means, yep, exactly. 9 is just 3 times 3. 25 is 5 times 5. Yep, you got it perfectly. It is the squares. So the problem is, what that means is when we come in here and we're checking the number 9 as our potential prime, we go up to this, we get to divisor of 3, and we say if it's less than the square root. So what that means is for the number 9, the square root of 9 is 3. 3 is not less than 3. 3 is equal to 3. So there's a cool thing we have to do. So this less than sign, we actually do a less than or equals. So the less than or equal to that you're used to in math, this is the way that we write it in programming. We just say a less than sign followed by an equal sign, and that's less than or equal to. So now we should include those and check 3. Let's go ahead and run it again. Oh, you're right, 4 was in there. That's funny. Okay, so now 4 is gone. So we have absolutely fixed it. Good catch, James. But now it's gone, and we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So that looks like the prime numbers. So that's awesome. That code really does what we think it does now. Okay, so before, we had done a really large number here, and we saw our program taking forever. I want to try running it again. Let's see if it's any faster. Whoa, that was a lot faster. Maybe we had one more 0? Seriously? You gotta be kidding me. RIP. I have so much memory on this computer. What's it doing? I don't even know. Yeah, no, we actually save before we run the program. I have no idea what just happened there. Something weird is going on. So welcome to programming. Sometimes your computer does weird stuff. Yeah, it's like this window. So it's like cursoring over this or something just locks it up right now. Alright, so here's what we're going to do. I'm going to show you guys something that I wasn't planning on doing, but we're going to do it anyway. So, I'm going to open up Visual Studio Code. Our program is right here. And what I want to do is this. Inside this window, I'm going to say... actually, I'm going to do this. I'm going to get rid of this window. Close it. And then I'm actually going to go to my Start window, and I'm going to type something called PowerShell. And you should probably have this on your computer. If you just type in the word PowerShell, it's written right up there, you should get the same program that I do here. Now what I want to do is this. I want to right-click on one of my files here, my program.cs, and say... Oh, actually, could I just open in Command Prompt? No, it's just going to do that one. And I want to say reveal an Explorer. So when I do that, it opens up an Explorer window in this place. Now here's what I want you to do. Hold your Shift key and right click in here, and you should see something like Open PowerShell window here. If you don't have that, what you can do is this. Click in the address bar, and now you won't be using the same thing, but you could say CMD and you'd get the command prompt. So that's one trick. So that opens up a command prompt window in this folder. Or alternately, I think you might even be able to type in PowerShell. You can. So if you type in PowerShell in there, so just click inside this spot and just type in the word PowerShell, all is one word, and it will actually open up a PowerShell window right there. So if you don't know that trick, you can, and that will actually get you a PowerShell window right in that folder. So this is the same thing that I was using inside of Visual Studio Code, it's just not in there anymore. So, oh yeah, Spooky Coder, exactly, yep, that's all you have to do. Yep. Oh, if CMD doesn't work, try PowerShell. They should both work. And yes, that was the one I showed in the beginning, Blue Spide. Hold Shift and then right-click, and it was in the context menu. So now that we're in here, we can type .NET, and I want to type .NET Run. And there it goes. And you'll see that it got us all the primes up to that. Now I want to add an extra 0 because I think that might have been the one we were going to last time. So let's run it again and just see how fast this goes. And yeah, if you can get a command window instead of a PowerShell, so there we go. Remember that I was talking for like a minute last time and it still wasn't done? This time it is so much faster, so this is great. Okay, so our code is so much faster, so thank you for the suggestions of not using as many divisors, and specifically going up to the square root. So thank you all for those. Those are very good. Can anyone think of any other things that we could do to improve this code? If you can come up with something, we can probably make this go faster. We might be able to add another 0 onto this and go even bigger, because if I add another 0 and then run this, you'll notice that it starts to slow down. James, what would we do recursion on? I'm not sure recursion would help us here. So see how fast that's getting? Like numbers are just like flying by. That's got to look crazy on the stream. I'm amazed I'm able to maintain the frame rate on this. That is still going. Move the square root out of the loop. That's a good question. I don't know if that'll speed it up or not. As is. So I'm going to hit Control and then C to cancel the program again. So the suggestion there from Blue Spide is to take this, and I think it probably will. We're going to cut this, and I want to say max divisor. Divisor. Sometimes spelling is hard. Max divisor equals this. So now when I do this, you're going to notice a quick problem here. So previously, this code worked just fine, but now it doesn't. And the reason why I'm getting this red squiggly line here is because the square root of the number 10 is 3 point something. And because there's a decimal place, I can't store that as an integer safely. Remember, we talked about the fact that an integer is a whole number, so we would need to store this as a float if we wanted to do that. Now, I could store it as a float, as we just mentioned, but I don't actually need to in this case. I think I can get a... Because we're doing less than, the only number we actually care about is one lower. So for the number 10, for example, we would need to do 3 point something, but since we were only dividing by whole numbers anyway... And welcome, Azza, thanks for following. Since we were only checking whole numbers anyway, we were only going to check 3. And since we're checking this number, that's where we want to go. So the biggest whole number. So we can always just chop the end off. So we're just going to convert it to an int, and then that's actually going to give us just the integer value. So it's just going to remove the decimal place. Now, for this, what I did here is a fancy little trick. So notice that I have integer, and int is inside of these parentheses, and right up next to this other value here. So when I write it like this, what this tells the code to do is, this tells it to take whatever value this is. In this case, it's going to be a number that has a decimal place, and this is going to say to convert it into an integer. And then that's how that's going to work. So we'll try this. We'll see if it makes it any faster. And then while this is running, I'll look at the stuff in chat. And roots. So let's go ahead and run that. That probably will be faster, actually. Okay, so, thank you for following Roots and Azza. Okay, so Ladal, how much time would it take to return the sum of the primes below 2 million? Probably not actually very, not necessarily very long, but we would need a new type, potentially. I'm not sure how big a number that is. Yes, Roots is also correct. So because we're outputting to the console every time, that's slowing it down a little bit. So, okay, but that definitely finished faster, but not a lot faster just yet. And then, this is the parallel link. Okay, so, I will catch those in a second. And welcome, Ladal, thanks for following. Okay, so this code is a little bit faster as is, so this trick worked nicely. There is actually a cool trick that I want to do as well. Let's take a look at what numbers we're dividing by. So, which numbers are slowing us down the most, do you think? Does anybody know? That is actually my big question. Does a prime number or a non-prime number, which one takes longer to figure out? Anybody know? So Blue Spide is saying to reduce the number of divisors we check. I don't really know. I learned all my Python in school. Oh, yes, you are correct, James. The prime numbers take longer. And, Astron, thank you. Welcome. So, yeah, so here's what we're... Exactly, so James has it correct. So it's the primes that take a long time. So let's go ahead and open up Notepad again, and we're going to talk about that. So, 97, right? 97 is a prime number. That's one of our easy ones. Let's change the program just so we can take a look at this number. So we're going to go back to 100, and I'm going to open up the PowerShell window again and run it. So when I do this, you'll notice the last number is 97. So, for 97, we checked 2, 3, 4, 5, 6, and then all the way up until we checked the number, what is the square root? So that would be 9. So we did 7, 8, and 9. Whoops. Comma. Okay, so these are the numbers we checked for 97. Yeah, except we actually only go up to 9 because it's less than the square root. Okay, so Ladal is actually making a really interesting suggestion here. So wanting to reduce the number of divisors. So what Ladal is suggesting is that we set our initial divisor to 3 and then divide by 2 and then increase by 2's. So here's Ladal's suggestion. We divide by 3, 5, 7, and 9 for this number. So because we're starting at 3 and going up by 2 each time. So that is actually a very good suggestion, but there's actually something more to it. So if we went higher, and instead of going to that number, we went one bigger, so we went up to whatever the one is for 100 or 1000. Let's do this. Biggest number in the set, 1000. Let me figure out what it is by running our code. 997. Okay, so 997. So in this one, because we're going up to 1000, what square root of 1000 is going to be what? Let's make it easy. Well, yeah. Either way, the point is we're going to go through 11, 13, 15, 17, 19, 21. Right, we're going to do all these numbers. So we're going to do a whole bunch of extra numbers. Okay, thanks, Astron. Yeah, it's roughly speaking 31. But the point is this. I would argue, then, that we don't need to check the numbers that are divisible by 3 either. Right? We don't need to check 9, because if it's divisible by 9, it was divisible by 3. So let's remove 9 from the list, right? Because we already checked that one. Which means that 15 goes away also, because it was divisible by 3. And then we can get rid of 21 as well, because it was also divisible by 3. So let's remove the numbers that are divisible by 2 and the numbers divisible by 3, right? Let's get rid of those, because we don't need to check them. Because they aren't, you know... why do we need to check if it's divisible by 6, 9, and 9 if you already checked if it's divisible by 3 and 2? Yes, Azza. Yes, exactly. Sorry, yep, you got it. So if a number is divisible by 9, it has to be divisible by 3. That is correct. Azza, so which numbers should we check then, if we're not checking these ones? 6, 8, and 9, yeah. So there's a whole bunch of numbers we don't need to check. So 6 goes away, 8 goes away, 9 goes away. Ladal, yes, we should only check the not prime numbers. Oh man, oh geez. If only, you know what we could do? Man, if we wrote a program that found prime numbers, we could use that in our program that finds prime numbers.
What a lovely day!
So, okay, so where are we ever going to get this list of prime numbers? Oh man, I have no idea where we could possibly get a list of prime numbers. If only we'd been doing this in order, in a loop, starting from the low numbers and gradually increasing, we could get prime numbers. Yeah, exactly, Azo. 2, 3, 5. Okay, so let's think about this here. So, we already have the prime numbers. I can't believe scientists use this program just to find out the biggest prime. This isn't how they find them, actually. There are other ways to do it, but yes, the same concept does apply of making sure it doesn't have any divisors. Okay, and welcome, Mike V. Pat. Thank you for following. Glad you're enjoying the stream. Okay, so yes, Ladal, they actually do. And yes, I do know these things. So here's what we're gonna do. We need to use a different set of numbers, so I'm going to teach you about a couple of new things. So we have talked about methods and things like that, but now we actually want to keep a running list of the numbers we've already found. So because we already found these numbers, we can go ahead and use them again. So let's do this. I'm going to change the program slightly. So let's keep a list. So I am going to show you, since this is for beginner programs, we're going to start off with a list. So, and this is going to have a weird syntax. So syntax just means like way that you, syntax is a fancy word for saying like the structure of what you type in a language. But let me just call it primes, And I'll explain what I'm doing here in a second. But let me go ahead and write it first. And will this do it for me? Okay, it will. Alright, so you'll remember I told you all to install the C# extension in VS Code. Now here's the reason why. Yeah, Wheelspin, syntax is kind of like a grammar. So I put my cursor right after the word list and then the open angle brackets and the word int. So at this point I can hold the control key and I can hit the dot key, the period. When I hit that key, it brings up this context. And in this context menu, it says a couple of fancy things. I want you to use that first option, and it's actually going to add this at the top of your file. Now this is actually called a namespace, and I'm not going to explain exactly how that works yet. However, we are able to use stuff outside of our program. So code that's not written here, the way that we're actually using that, so the things that help us, like the method that figures out square roots for us in math, and writing stuff to the console window, that's all coming from here, this using system. That's why we're able to do that. The next thing that we want to be able to do is access this collection. So we said we wanted to be able to keep a collection of all the prime numbers we'd found already. So you'll notice it says System Collections Generic. So I'm not going to explain technically what a generic collection, how it works yet, because there's a lot of complexity to that. But if you just want to use one, all you have to do is say list of int. So this just means I want a list of ints, and that's the way we read it and say it in programming. If I, for example, wanted a list of strings, as I'm betting a lot of you could guess, I would do list string, like this. And then then this is a list of strings. So, you know, I could do like a list of names, for example, and it would look like this. So that's just some basic understanding of how that works in C#. Okay, let's tell your list what type of data can... Yes, exactly, Aaron. The brackets, yep. That is exactly what they use. That is what the brackets are for. Awesome, thank you for answering that. Okay, Mage, can I answer a question? You've learned Python, and you like it very much. Should you learn a more popular language like Java, or by C, did you mean C#? A C-type language like a C# or a Java has a lot of value to learn because of the fact that there are so many people that know it. There are so many programs written in Java and C#, and so it will take you a long way. So there's a lot of code you can look at with them. Python is also a very good language. So Python is something that's very good for beginners. I actually used to teach Python at a university to non-programming majors, so people that were just learning to code. So yeah, you can totally learn Python in a place like Code Academy and things like that. So it's very good. Python's a fun language. It's one of my favorites. But if you are looking for something, I do actually recommend picking up a C# or a Java. Now, obviously, I recommend C#, but I use C#, so I'm slightly biased. But Java's not bad, so it's not my choice. But plenty of people do use it. It'll take you a lot of places. Question for me, are you going to implement it later that your loop will only look at every second number? No, we're about to actually change it so we only look at prime numbers. Oh, you meant the outer loop, and yes, we will probably change the outer loop. Okay. Wheelspin, that is unless .NET Core becomes the language that people use on IoT. So people are running .NET Core on those. Yep, yeah. You meant the outer loop. Okay, so let's do that one first, actually, because that one's a simpler one. So this suggestion is, in this outer loop, why are we even bothering to call the isPrime method for the even numbers? So that suggestion is that we just add 2 to the list. So let me finish this change that we're going to make here. We're going to use the list that we just created. But then the first thing I'm going to do is I'm going to simplify the outer loop as Pyro suggested. So let's start here. So primes, what I want to do is I'm going to change this code. So I'm going to say if it's prime, we're going to add it to the list. So I'm going to say primes and then dot. So when I hit dot, that means I want to use a method that's part of my primes object. And you'll notice it pops up with what's called IntelliSense, and I told you about this last time, but these are all the suggestions for things I can call on that. So when I do add, that lets me add an item to my collection. So I'm going to add potential prime. And you'll notice this works just like all of our other method calls. We just say primes.add and then pass in our variable of potential primes. So now I want to take this code and I'm going to move it out of here and I'm going to put it down here. So now that I have it down here, we want to print it out. And there's a change I actually want to make. Let me take a look at the questions in here, because there are definitely some questions. Does .NET Core work on embedded like for an Arduino? Aaron and Cincy, yes, there are people that use it on like Raspberry Pi, and it's getting to more places. So I fully expect .NET Core to run on all the little mini devices. Soon, if they're not on all those little things within a year, I'll be really surprised. And yes, James, I added this using statement to the top, and the way that we did it was after we typed in list int, we then went beyond this line and hit control dot to add it. And then, yeah, so we're gonna, probably in the next stream, so Azza will be explaining what the difference is between a static and a non-static method. Not sure about embedded. So, okay. Yeah, I mean, yes, Aaron and Cincy, it is a different world, but I would not be surprised if they don't get us there. We'll see what they do with it though. Okay. So we have this list of potential primes. Now I'm going to do a fancy thing here that I want you to just kind of go with. So the string type that we talked about before, we used this when we did strings. I want to say dot and join. So this is a static method on string. So remember I pointed out that we did console.write. So this is string.join. It's the same concept. And what I'm going to do is I'm going to pass in a couple of values to this. So the first thing I'm going to pass is a string with a comma. And then the second thing I'm going to pass is my IEnumerable. So I'm going to do potential prime. No, not potential primes. I'm going to do primes. So that will actually create a string that contains all the values in that, and they'll be separated by a comma. So now I want to do a console.write, a write line I'm actually going to do here, and I want to pass this in here. So let's say string, and I'm going to call that string output. So we create a variable right here. We do string.join, and this is going to make a variable that it's going to make a value that we're going to store in this output variable and pass it to our console write line. Exhibitioner, welcome. I should say welcome back. So when we do this, our code should still work. So let's go ahead and run it again. We should end on 997, I believe. So looks like the code still runs. So all we did was we changed it. So we now store the values inside of a list. So hopefully, if anybody's following along, that should make it a little easier. And yes, Pyro is correct. So our list, you'll notice, is kind of cluttered because we always have it right next to the previous one. If we had a space here, that ought to make it a little clearer. So I'll run that. I save it and run it again. Now we've got a nice good gap between these, and you can see what all the values are. Can you repeat the list part? Yeah, Rubik's. No problem. So, this is the way that you declare a list in C#. You just say list, and then you use an open angle bracket, and then you put in the type of value you want stored in the list. And then that is what the type, that is how you write the type. And then other than that, it works like a variable declaration. So you do this. So that creates a variable called primes. If I wanted to make a string array of a list of strings, for example, I could do it like this. I could say string instead of int, and just put those in here, and I might call it, say, like names. So if I want a list of names, this is how I would write it. Now the way that this works is the same way that we get access to things like console and stuff like that, is actually these namespaces I'm including at the top. So I included a using statement, say using system, and that gives me system.console, system.math. So that's how we got access to math.square root, was this as well. So this basically says, include this library that's already in .NET Core, and let me use it here. The same thing works here. So we're using system collections generic, and this gets us access to our generic collections. So it's called generic because we could do a list of strings, a list of integers, a list of floating point numbers. We could do a list of whatever we want. And so that's called generic. And I'm not going to explain how that works just yet, but it is a cool thing that is available in C#. So I'm going to get rid of the strings one. The next thing that I do want to talk about, because this is the first time we've seen it, is I said create a new list. So this actually creates a new empty list object that's in here. So this is a structure we haven't seen yet. You're going to see all the time in C#, this idea of creating a new thing. Now that, for anybody that does know, that means that this is a class. Oh yeah, Rubik's. So yes, the reason why is that a list will automatically grow as it needs to get larger. So as I add items, the list is going to get bigger. If I used an array, it's a static size. Now with an array, I could always make a new array that's bigger, and so I could do that myself, but a list is basically doing that part for me. Yeah, exactly. That's a great answer, Matthew. A list is basically an array with extra methods, extra functionality. And Rubik's, an array can grow, but the way that it grows is you actually throw it out and get a new one. That's the funny part. So that's actually part of how that works. So there's some other things with like strings. There's stuff languages, yeah, there's stuff languages are doing underneath the hood that we don't always see. So that's why for now I'm telling people just use it this way, and we'll explain some more of what's going on underneath the surface later. So that's kind of the way it is with programming. You want to get the best understanding that you can now, but if we don't get you coding and writing fun stuff that you enjoy, then there's no real reason just explaining the theory to you the whole time. But we'll get to that theory, because it's important. Because if you don't eventually know it, you'll run into performance and issues and bugs that you can't explain your way out of because you didn't know how it was working. So we'll get you those eventually, but you don't need those on your, at this early level. So, okay. So we're now storing these in a list, and all I do to add them is I say primes.add potential prime into the list if it's a prime. So only when it's a prime we add it to the collection, and then we output that whole collection by joining the list together. So we basically said, take each item in the list, join it together as one big string, and separate it using this value. So this is a special method that does that. It just takes a collection and turns it into a string separated by that value. So it's really cool. And Exhibitioner, I don't know, but let's talk about it later. Join our Discord so we can chat about it if you didn't already. I don't remember if you did yet. But I will go ahead and link our Discord and chat there. And actually, that goes for anybody that wants to chat with any of us about this. Kato, Grennan, Adam, welcome. Thanks for following. And hello. So we're actually using C# 7.2 right now. Sorry, 7.0 right now. And 7.3 is the current version of C#. And I do a lot of talking about that one. So in our regular streams, we're using 7.3 if I'm not mistaken. But then on this one, this is a learning C#, so we are using 7.0, and that's just because that's the default. So everybody is just going to jump into this, and I'm not going to worry about explaining to you what the different version differences are, because they're very minor on those. And actually, the default, even when you are programming in C#, if you don't ask for it, you're actually in C# 7.0 anyway. Okay, so that's our current program. So Pyro had suggested an improvement. So when we run this, it takes a while to go to a big number, like say you know, 100 million. So we're going to find all prime numbers under 100 million. And when I run this code, it's actually going to take a long... Well, it didn't take that long. Let's go higher. We're not going big enough. Go big or go home, right? So the challenge is because we don't print until the end, we don't see anything until it's done. So our printing time isn't a factor. So it takes a little bit and then it runs. Now I want to show you what number we're actually going to. So a cool trick in C# that we can use is we can actually put underscores inside of our number literals like this, and those underscores don't actually mean anything. So we could put them wherever we like, in whatever way helps us to read that. So let's go ahead and do 100 million. Yeah, so this gets so much faster when we do it this way. So there's a lot of improvements, and even on this, you'll notice it's taken a little bit of time to figure it out. So what I want to do is I want to find out how long it's taking. Whew, man, that's taking a while. Look at that. I'll let that go. We'll come back to it in a minute. Actually, how worried am I about how long that's taken? Yes, Python is not as fast as .NET Core. That is absolutely true. It would work, but you would want to order the list afterwards. Okay, so that is taking a while. So I'm going to go ahead and cancel that. And the way I do it is I hit Control-C, so that cancels the code that we were running. And then the next thing I want to do is this. I'm going to reduce this back down so that we're a small number again, and that lets me confirm. .NET Core is definitely faster. .NET Core is basically the new lightweight version of .NET. It is very, very fast. They've been doing a lot of benchmarks on it. And yes, it is much faster than .NET Framework. So .NET Framework itself is not faster than than a number of things. So there are benchmarks out there, Cod. I do not have one handy right now because we're doing this. Okay, so potential prime 2. So the suggestion that Pyro had made was that we don't even bother asking if the even numbers are prime. So he's suggesting let's just check odd numbers, which is a nice improvement we could make. So what I want to do is this. And there is actually an easier way to do this that I'm not going to tell you all about, but we're going to do this instead. So we're going to say primes.add2. So we're just going to add the number 2 to our collection. Okay, so once I add the number 2, we don't need to start there. So we're just going to say we know that 2 is prime. No one's ever going to run this code for finding a number, for finding no numbers. So we're going to say start this collection at 3. So our outer loop, int potential prime equals 3, is our new starting point. So if we run this code, this should work fine. And remember, I told you, just run your code. You don't have to do the whole thing that you want to change. Once you think it should work, just run the code again. That is the best way to test it. So it works, 2, 3, 5, 7, right? We didn't end up with 2 2s. So our change worked. The next change that we want to do is we want to change this. So remember I told you that potential prime plus plus is a fancy way of saying potential prime equals potential prime plus 1. So it's a fancy way of writing this. But there's an even fancier way of writing the same thing for writing this code that Ladal just mentioned in chat. And what we're going to do here is we're going to say plus equals potential plus equals 1. Matthew, thank you for the follow. Much appreciated. I hope that means you're enjoying the stream. Okay, so this code is also the same. So potential prime plus equals 1. Now plus equals, and there's also like minus equals as well, as you could probably guess. But plus equals just says add this value to it and store it in itself. So this means like potential prime plus 1 and store the value back inside of it again. So if potential prime has a value of 3, then we're going to say now potential prime is 4. And if you run it again, it's going to be 5. So because of the way that works, we can change this to say plus 2. So now in our collection, our numbers are going to increment by 2 each time they go through the loop instead of just by 1. Yes, Ladal, there are lambda expressions in C#, and they're actually they're used in a variety of places. So we have fairly comprehensive lambda expressions, and they're pretty easy to use. Okay, so that's how this works. When you do this, this should now do 3, 5, 7, 9 as it goes through the list. We're going to run the code and make sure that it still works. And when we run it, you'll see that that comes back with the same collection we had before. So we're pretty sure this code actually does what we want. So let's go big again and see if we manage to improve things at all. Yeah, it should be a little faster. So we're going back to the big one. This is the one we canceled last time because it was taking so long. We'll see if this made it any faster. Not quite fast enough yet. That's still taking a little while. Don't worry. We still have other improvements that people have mentioned that we're going to put in here. Okay, so that still takes a while. No, that's what we expect. So, for example, if we shrunk this a little bit, right? If we just did one fewer, this probably doesn't take that long. So the challenge is, it's our really, really large numbers. We're checking too many things in the very large numbers. So remember, going up to 10 times as big a number could take more than 10 times as long. Nice. Have fun with that install. I added something like this from what I learned. Find prime number, console read line out into user input. Find the prime number 2. Oh, so you want to parse in the value and then use the user input as your method. That is a very cool idea, Rubix. Awesome. Glad that is good that you have that. Yes, we have great speed even at 10 million. So it's just 100 million. We're not quite 2 yet. So let's see if we can get 100 million. And yes, Rubix, we will probably add that. Give an initial size to the list. Ooh, that's a good idea. So how big should we make the initial list? We could make it a good deal bigger than it is. What? We're probably going to have 1 million prime numbers if we try to go to 100 million, right? Well, we'll do 500,000. We'll start it there. I think that's how you initialize it with a size, I think. 5,000? 50,000? We'll do 50,000 prime numbers. I don't know how many prime numbers we actually need to store. So let's try this. We'll see if that makes it any faster. Oh, did we switch it? Nope. Go big again. So we're going to try the big one again. We'll see if this is fast enough yet. So that was a suggestion. Make the list bigger. So anybody that was here earlier, someone asked why we didn't store it in an array. So a new programmer, you don't know what an array is, but that is basically just a contiguous set of memory. So just a straight in-order set of memory that you can store a list of items in. Now the problem with an array is that the array doesn't change size. Because it is a contiguous block of memory, when you need to add it and make it bigger, you don't have space. You're going to bump into other objects that are around you in memory. So what you have to do is you have to make a new one and move all the values. Yes, exactly. So Pyro's correct. So the problem is early on we're not like that isn't our number. So our collection was getting big enough at first that wasn't an issue. So let's do this. So what we want to do is we want to change how we do our calculation. So let me switch this back to 100. We're going to run our code again, just make sure everything still works. It does. And now we want to actually change how we figure out what a prime number is. So I had this stored here. Now I want to do something fancy with this. I'm going to move this collection up here. So I cut that and I paste it now outside of our main. Now the next thing I need to do is this. There's a special word called static that you notice on the main, and I used it down here in our isPrime as well. So the word static. You need to add that before this in order to use it the way that we want to use it. So by moving this up here, I have now done something that isn't going to be great for like long-term coding. So like if we're actually like building professional program, this isn't the way that we do this. We do this something else, another way. But for explaining to beginners, this is a pretty good way of showing you how it works. So in professional coding, we organize our elements a little differently, but you guys are just trying to understand the pieces we're working with. So don't worry about trying to put things in the right spot. There's plenty of time to learn that later. For now, just work with code and figure out how it all works. So inside of our program, we just moved this up here. So what I want to do is this primes value. So you'll notice it's no longer inside of my main method here. So this is a main method that we talked about. This isn't inside of it, but I can still access it, which maybe gets you the hint that because it's out here, I can access it down here as well. So I can now use primes down in the other method. So that's really neat. Okay, what are people saying? Much impact, to be honest. Okay, well, you just add one thing into the list, you have to delete array and create a new one. Yeah, Ladol, sometimes, but the trick is that the list grows bigger than that. So when it does need to expand, it's like getting larger at a rapid rate. Okay, so this is our maximum divisor that we need to check. So what I want to do is this. I want to use the next type of loop that we talked about. So we talked about yesterday, we talked about the while loop, we talked about the for loop, and we talked about the do while loop. But the loop we didn't talk about is the for each loop. And the reason we didn't is because we were going to talk about it today. So notice that one of these options in this list is for each, and I'm going to use the lower one. So remember, when you're using this IntelliSense, always choose the one that says it's for C#. So that's this here. It says for each statement C#, and when I hit tab, it creates this structure for me. And it's actually going to let me tab through these pieces as well. So I'm on the word var right now, which I didn't explain to you guys, but I'm going to type the word int instead. And then the next thing I tab to is the word item. And instead of item, I want to put in the word prime. Prime, singular. And then here it says collection. So I'm going to say primes because that is our collection. So once I do that, so just look at this code. Don't pay attention to the rest of that. Just ignore that right now because Ladol is correct. There's a little bit of complexity here and I want you to ignore that. Don't pay attention to that just yet. We're going to get to it in a second. So this basically says go loop over this collection and get me each item. So each item in the collection is going to be given to us. So we're going to get the prime number first. Yeah, so this is how it works, Rubik's. So this is a collection, and this is each item in that collection. So essentially in here, whenever we use prime in here, so if I say if, if, there we go. If potential prime, and then we'll say divided by the prime equals 0, return false. So that means that this prime is actually each item in that collection. So every time you go through the loop, it puts the next value into that variable. So the prime variable always contains whatever the current item is in the collection. So we're just stepping one at a time over it. Yep, as Pyro said, it works how you'd read it, which is kind of weird because, okay, something I want to address for everybody that's in here. When I or anyone else says that something is easy in programming, that doesn't mean it's easy. I want to make sure I'm clear about that because I don't want anybody to feel like, oh man, I'm not getting this or anything like that. What I want to tell you is this, and this goes for any skill level of programmer. Programming is complicated. It's difficult. We do a challenging thing. You have to think, you have to solve problems, but what makes it nice and easy is there are some things that once you understand it, and you understand how it works, then it's easy. So the idea is, this concept is hard, but once it clicks, like once you get it, then it's usually easy to work with. So when we say something's easy, that's actually what we mean, is once you get it, it's easy to work with. So that doesn't mean that you get it immediately. So I want to clarify what I mean if I say that word. So that's usually what it is. And we try to simplify things because the most important thing in programming, sometimes performance is important, but the first thing that's important is that your code works. Your second most important thing is that it's readable. And then the third ones are things like how fast it is, how efficient it is, and stuff like that. But the most important things are, can you read it? Does it work? Ladal, yeah. So Python is also related to the same languages. So Python and C# are pretty similar, actually. Okay, so this for each loop, and actually, if I remember correctly, yeah, the Python, a for loop is actually a for each loop, if I remember correctly. And Dylan, yes. Oh, I let the other one through, Dylan. Yeah, it can figure that stuff out. Yeah, so, okay, so this is how this works. So we're going to say this. This code is not quite right yet. So that is going to replace our previous code, except we need to do something. So I said for each int prime in primes. So what I want to do is this. We don't want to check all the primes. We only want to check primes up to the max divisor, because we already said we only needed to check up to the max divisor. So I want to make a smaller list. So I want to do I'm trying to think of a way to do this that's nice for you guys. Let's do this. You know what? We're not going to do the divisor just yet. Let me see how fast this is here. So we're just dividing by the prime numbers. This might cut down enough, but it might be better to do the square root. I'm not 100% yet. We'll see. Yes, I did hear about that, Dylan. Okay, so we're going to jump back up to the 100 million and see if it's any faster like this. This might actually be slower. Nope. That's still taking a while. Okay, so we're going to jump back in here, and we're going to do this. We're going to add this piece here, so this divisor piece. Remember, we're only checking the prime numbers now, so we're taking our numbers and we're trying to divide by potential prime numbers. So we're trying to divide our potential prime number by lower prime numbers. So here's what we're going to do. I'm actually going to show you guys a thing that I wasn't planning on showing you yet, but we're going to put it in here. So I want to say dot, and then I want to say where. So remember, I have this collection primes. Now I want to limit this collection. So the way I'm going to do that is I'm going to say primes where, and then I'm going to say, whoops, p, and then p dot, actually p less than max divisor. Okay, so I just did a fancy weird thing here that I'm going to explain, so don't let this scare you just yet. This is a weird thing. You're going to run into it all the time in C#. But I'm going to show you how it works. Can't you simply return false if prime's greater than max? Spooky Coder, yeah, I could. So the other option, yeah, so Spooky Coder's suggestion is that I do this. That I come down here and I say, if prime is greater than max divisor, return true. So this is actually what Spooky Coder is suggesting that we do. And we could do that. So we'll do this. We'll say if it's greater than or equal to the max thing, then we could return true. So there's the suggestion from Spooky Coder, which actually will work nicely. So we'll do that. Let's see. Yeah, PCs only handle 1 and 0 quantum computers with respect to basing. Why not if and then break inside the loop? Probably easier to get. Yeah. That's a good suggestion. Instead of return, you could also just break out. Yes, I could just break. And it'll do the same thing. So the thing that people are suggesting is that we do a break. Now, I'll explain to you how a break works, because you all have seen return already, where that returns out of the method and gives back the value at the calling point. But if we do a break instead, what that says is, it says if we're inside of a loop or something like that, break out of the loop. So in that case, this for each loop is our loop. And break says, go ahead and get out of this loop. Regardless of where we are or what we're doing, just get out of it. And so it'll exit the loop right here at this end brace and go to the next line. And then that is going to return true. So I can just do that. We're saying if we're past our max divisor, go ahead and break out and just return true. Okay, Fraggle Rock, you're not allowed to ignore. I would limit this chat to just C# basic programming questions. Yeah, Fraggle Rock is actually probably right. We should probably lay off on the Q# for now, because that's probably a little bit above what most people want. But yeah, we don't have to limit the question. So if you have a question that's more advanced than a beginner question that you want to ask in the chat, go ahead and ask, and I will ignore it if we can. But it is probably beneficial to the beginners if most of the typing in there is related to that. But we're not going to be super strict about it, so if you want to bring something up, that is actually fine. And anyway, let's go ahead and try this. So we are just doing those 2 checks in there. This should be set to 100, I think. No, it's set big. Oh, Seb. Yeah, no problem. There is a video. So anybody who missed the beginning of this, afterwards, you can actually watch the video. It's up in the video section here on Twitch, so if you do ever miss one of our streams, you can actually check it out there. So that's what Seb's talking about. And also, have a great night, Seb. Thanks for stopping by before you went to bed. And thank you for the biddies, Seb. Much appreciated. Yeah, so our next stream will actually be on Thursday, so I hope to see you there. No, Tuesday. Today's Monday. It'll be Tuesday. It'll be tomorrow. So tomorrow we're going to be doing a programming stream, Project 1. So back to our regular stuff. So it'll be a higher level than this. So not a beginner stream tomorrow. But beginners are still welcome. You can always still watch what we're doing. And there goes the program. We're going to have Simon Timms on as a guest. He is a Canadian Microsoft MVP that is going to join us. He's a fun guy. And he's going to be up in the corner up there. And we are going to pair program, so he's actually going to be controlling the code on my screen, and he and I are going to write some code together, so it should be fun. And welcome, Janisku. Hopefully everybody is enjoying the stream so far. If you have questions, seriously, even if you just walked in, go ahead and ask your question, and we will explain. Sounds great. We'll see you tomorrow, Seb. Okay, so this code ran. And it took a while, but it was able to find all the prime numbers below 100 million. And let's confirm that that really worked, since we didn't actually check with the small scale one. 2, 3, 5, 7, 11, and we're missing, so the squares are not there, which is good, and we go up to 97. So it looks like the code works. And yeah, we're using the set up to 100 because we can sort of eyeball it and just check. Obviously the code will go a lot higher than that, though. Okay, so any other suggestions for ways that we could speed this up? So we got a handful of things. So this is actually pretty quick now, because we're able to get to the 100 million, which in itself is a difficult thing to do. That might be about the extent of what we can get out of this. Yes, Pyro, we could multi-thread the isPrime for each. What a great idea. So most of what we do on this stream is C#. We do a little bit of JavaScript, some HTML, we'll occasionally touch CSS if we need to, and I have some guests that are planned, that I'm planning on bringing on, that we don't have dates for yet, that are JavaScript programmers and some programmers that specialize in other languages as well. But most of what we do here is C# and .NET Core, DSAC 7. If you haven't checked out C# and .NET Core, if you usually focus on another language, I would actually still recommend you stop by on the other streams, because C#'s actually changed a lot from. I'll often hear like people out of the Linux community talking about it. It's like, no, it's not like that anymore. It hasn't been like that in a decade. Actually, with your old code, you could have actually multi-threaded the big loop. That is pretty true, Pyro. Because we did not need to know what any of the other ones were in order to create the list, because it didn't require, like, when we first went to do this, once I changed this, we could no longer multi-thread. But just having a collection we added to, that was possible. Okay, so that, I think, works pretty well. We talked about methods. We made our isPrime method here. We created collections with this. We used methods on the collection to add in the things. We created some variables. We worked with the for each loop. What else did we look at? We looked at a few different operators, like the modulus operator. We showed the greater than or equal to and the less than or equal to operators. We looked at the plus equals operator. We looked at string.join as a way to merge a collection together. We looked at the math square root method. What else did we cover in here today? Lots of things. We talked about how to break out of a loop, and that works for a for each loop as well as a while loop or a do while loop or a for loop. Any of those. What else did we cover today? Lots of stuff. We talked about a little bit about statics. We mentioned the Boolean values, which are true and false. So remember, I should point this out. Remember that we have variables. And when we declare a variable, we say the type. So we said it's an integer, and an integer is just a fancy word to say that it's a whole number. If you don't remember your math class. So some of us are... It's been a while since we were in an actual math class. But our integer numbers are ones like these. And so when you declare a variable, you tell it what type it is. So they could be an integer, they could be a string, or in some cases they could be a bool. So when we declared our method, I want to point this out to you. Notice in our method we said bool is prime, and so what that means is that this method actually returns a Boolean value. So I could have stored that in a variable, and I'm going to show you this just so you see it. It is prime. So I can say bool it is prime, and then put this in here. So let me show you this. It is prime. I could do this and essentially take the result of calling that method, that Boolean result, store it in this Boolean variable, and use it inside this if statement. So, oh, Rubik's, you posted a link. Okay, so, let me see. Could we throw in a timer that shows how long it takes to run? Major Babu, yes, we absolutely can. And then we could also let the user choose our number. Is there a schedule when you stream, and if so, is it more beginner, advanced oriented topic? Okay, so there are actually a couple of things. So first off, if you use our schedule command and pass in your offset of UTC, which mine is Eastern time, you'll see that is the schedule. So we have a command for our bot that does that, and we programmed that bot on stream, including that schedule command. You can also scroll down below if you're on Twitch, and you'll see our schedule listed below, and that's our regular schedule. But then, if you are talking about of specific things, then you want to go here, and that is our stream info. So that link there will get you to this page, and this actually has our our schedule that we're doing, which actually I need to update, because we are on this date right here. So Learn to Code in C# episode 2, and then tomorrow we have pair programming with Simon Timms, and then we got Thursday, and then things like that. So yeah, so if you want it in UTC, that's what Ladal just did there. And Polycypher, welcome. So that is what we've got there, and the link that Rubik's posted in is this one. So if you want to see any special events, so all of our Learn to Code streams that we're doing, I'm doing as events that are actually on our stream here. So if you go to, well, the URL that I posted in chat, which is Twitch TV/DevChatter/events, you'll find our events right here. So you'll see past events listed are these ones right here, so that's episode 1 and 2 of this, but our next ones, episodes 3, 4, 5, and 6, we have scheduled out for our Learn to Code. So if you want our beginner level streams, these are the ones you want to attend, and if you go to this page, you can actually click the Remind Me button, and Twitch will remind you that that's coming up, so you don't miss it. So yes, and that should be good. So, yeah. So those are what we've got there. So the suggestions, I will tackle a couple of those suggestions that people had. So Rubik's had suggested that we let this number be chosen. So here's what we're going to do. So we're going to do what we did from last time, and we're going to say console.WriteLine, and we're going to ask the user how high they want to go. We'll find primes for you up to we are finding primes. How high should we go? Question mark. There we go. Console.readLine. So this is going to tell it to get us the value that a user types in.
What a lovely day!
And welcome, Xdestrus. Thanks for following. So we're going to do int.parse. Actually, we're going to try parse it. And then we're going to say console.readLine, and we're going to say out int, and we'll say max number. So we're just going to put that in there for now. And there are some tricks we can do to make that work a little bit better. So let's look at some things. What's the difference between Visual Studio Code and Visual Studio Pro? InMug, so Visual Studio Code is actually just a text editor. So it's not actually a full IDE, it's just a text editor. And it's actually commonly used not just for .NET stuff, not just for C#. It's used by for people that do JavaScript and various other languages. So this is Visual Studio Code. It's lightweight, it's just a simple editor. It has a lot of cool functionality and extensibility that makes it really nice. It's actually the most popular editor for people that use Stack Overflow, if you know what that is. And Visual Studio is a full-blown interactive development environment with all kinds of debugging and other support, tracing and other things like that, which are fancy words that people that aren't programming much yet won't even necessarily know. And welcome everybody from Polycypher's stream. So the idea there is that Visual Studio is a full-blown IDE. It's huge, so the reason why in our beginner streams here we're doing VS Code is that it's a quick little install that you can use, and that will just help you out with, like, beginner wants to get set up, they can get set up in like 5 minutes if all they're installing is VS Code. So it makes it a lot easier for us here, plus it's lighter weight. You could run this on any computer. VS Code works on Linux, it works on a Mac, it works on Windows, so no matter where you are, you can actually follow along with us. Okay, so problem with the user inputs is you have to control the input. Yes, Rubik's, and we're actually not going to worry about that yet, but I will talk about that in a later stream. So now that we know how all these various loops work and these methods, we're going to look at how to control that input a little bit better. And yes, exactly. Awesome, Polycypher. Appreciate it. And Polly, you know a little bit about programming. You could totally join in this stream. Okay, infinite loop, which is only left when the input is an int. I have an infinite loop? Where's my infinite? Oh, Ladol. Yeah. Yeah, I could make a loop around that. Yes, I'll show that later. Yeah, no problem. It's useful information for everybody. That's why I answer the question. So there aren't bad questions in chat. Like, if you ask a question, I'll answer it, and it a lot of times will provide value to everybody. So even though you're the one that has the question. Okay, so once we do that, now this code should actually let us specify that ourselves. So I'm going to say .NET Run, and it should ask me now, how high are we going? So we're going to say 100, and hey, it works. Okay, so now we can do it. We can run it again, and we can say 1,000, and hey, it works. So now we have user input. We don't have any safety on that, so if they type in a bad number, for example, if they write the word 5, we came back with 2 because we put it in the collection. So it doesn't work perfectly. Okay, so that is actually how that piece works. Then the next thing someone suggested wasn't just passing this in. Yeah, Pyro, I could do that. I could also loop on it. I could do a do-while on it. So that's really what we do, and in fact I do that as a method of getting the user input and write it that way, but that's a little complicated. So we're not going to worry about that just yet. So we have this piece here. There was another suggestion that someone had made other than this one. So let the user input the number. And then someone wanted a timer. Yes, someone wanted a timer. That was the other thing that was suggested that I do want to actually get in here. Yep. I got it. Thanks. What is it? It's stopwatch, I think is what it is. I think that's the object I want. Someone might remember. Is it stopwatch like this? System diagnostics. Okay, so remember I told you before when I did the list that once you had the type it would red squiggly it and you just had to be on it and hold control and hit the dot key? This actually now suggests stopwatch using system diagnostics. So remember I told you before these namespaces include extra functionality that you might want to use. One of them is system diagnostics. And this namespace gives us access to the stopwatch. And it's actually stopwatch like that. So lowercase w. So in programming, all these things are case sensitive, so make sure you get that right. So stopwatch SW equals new stopwatch. And then what I want to do is this. I want to say, right after we ask them, well, actually, let's leave it there. Right after we ask them for their number. So we want to get their input first. We don't want to measure the time it takes the user to tell us that. So we're going to say stopwatch.start. So we're going to call it start method. And this is just how the stopwatch works. You can go online and look it up. And in fact, I'm going to show you all that because if you're programming, you're going to need to look this stuff up. Not that stopwatch, C#. This stopwatch. You can actually go to pages like this and find out how it works. And so I'm not going to actually make you read through this, but you could actually go down here and you could look and see like an example of some code using this. So this kind of information is available. So if you don't know how it works, go ahead and do that. And yeah, I always make incognito windows for things I don't want to keep in my history. Okay, so once we do that, I want to do this after we print it out. So we're going to see what the total elapsed time was. So we're going to say sw.stop. And then I want to say sw.elapsed, and this is a time span. So I'm going to put it in seconds. No, we're gonna see what it gives us. I don't remember what this is actually going to print out, but we'll find out. So we'll do a write line, and we're going to print out that value. So we're going to say stopwatch.elapsed, and that should be the elapsed time that happened. The reason we're using VS Code instead of Visual Studio is because it's more beginner friendly. So easier for someone to install and set up Visual Studio Code than it is to install full Visual Studio. So we're going to go up to the number 10,000, and you'll see that that took that tiny... Oh, yeah, look at this amount of time. That tiny fraction there. I don't know how well you guys can see that, but that is, you know, took no time at all. So let's run this again. We're going to try this with a bigger number. So we're going to do 1, 2, 3... so that's 1,000, 10,000, 100,000, million. So 1 million. That took 0.25 seconds. Let's try it again. So going up to 10 million. We'll see how long it takes to go up to 10 million. That took 3 seconds to go up to 10 million. A little over 3 seconds. How about we try 50 million next? So we'll do 50, 1, 2, 3, 1, 2, 3. And this should take a little while, longer than 3 seconds. What do you think? Maybe 15 seconds? Something like that? Either way, it's crazy how fast it figures out all these prime numbers in this code. So, you're thinking 30 seconds, Pyro? We'll see how long it takes. Whoa! Look at it printing all that out. 23 seconds. There you go. It's kind of in between us there, Pyro. Like right between us. That was pretty good. Okay. So that ran pretty well. Ladal's question of can I input it with underscores? And the answer to that I believe is going to be a no unless we told it about it. But that gets into some complexity that I don't want to do just now. So see, it didn't read that correctly. But I think, I might be able to get away with this. Nope, I can't. So there is a way to do that, and it's actually pretty easy, but I'm not going to show it right now because I haven't really covered parsing all that well yet. Nice, Rubik's. Okay, there's a way that you can, but you don't want to cheat every prime number. Yeah, so, okay. So there are a whole bunch of other things that we can do in here to improve this, but I think what we've got here today is actually not that bad. I like where we got to. We wrote an interesting program. Yeah, that's not the way that I meant there, Pyro, but yeah, that would work also. And I think that's actually pretty good. So, I guess I want to talk for a couple of seconds about a few things. So, as I mentioned before, if you are interested, you can take a look at all of our code. We actually have it out on GitHub, so github.com. GitHub is actually a source code repository. So I push all of our code out here, so every project we work on the stream is actually right in here, inside of this list at github.com/devchatter. And if you are interested in chatting with any of the other DevChatter viewers or me during the time when the stream is not going, the best way to do that is to join our Discord, which I also just linked in the chat there. So you can check out our Discord there. And if you are interested in getting any updates and other things like that, you can follow DevChatter on Twitter. You could also follow me on Twitter. My name is Brendonius on Twitter. So obviously I'm Brendan, and I go by Brendonius a lot of places on the internet. And let's see. What other stuff do I want to mention? Oh, I want to thank a few people for hosting us today. I think we got hosted by Visual Studio and C# Fritz and Polycypher. I also want to make sure that I tell everybody about our upcoming streams. So I mentioned tomorrow we're going to have Simon Timms on the stream. He and I are going to do some pair programming on follow DevChatter, or I mean Rubik's. So DevChatter technically is our whole community. It's not just me. So you guys are part of DevChatter because it really is a community of people. Like, I mean, the stream. So the stream would be okay without you guys, but the audience and the other people talking in the chat, you guys are absolutely part of the stream. So DevChatter is not just me. It's me and all of you guys. But I am Brendonius, and DevChatter is the channel we're in here. And I have no idea why people are crying in the stream. So, Their sad face emoting there. But anyway, also wanted to thank everybody for stopping by and chatting, and especially the people that were helping out with anyone that was asking a question. So if you were chiming in and helping out answering questions about programming, I really appreciate it. So thank you for supporting your fellow developers. It is a great thing that you're doing. I want to thank Seb for cheering. I greatly appreciate the 25 bits. And I look forward to seeing you at the next stream. And everybody else. So again, if you are a beginner, I hope you've been enjoying these beginning streams. Our next one is actually not going to be for a little while. And thank you for the follow, MPH. The thing I wanted to mention is if you are a beginner and you want to catch our next stream, make sure you check out our events section. It'll have the details on when our next Learn to Code streams are. The next one's actually not going to be till July 16th, so that's actually why I did 2 in a row, is because I'm not going to be able to get to the next one for 2 weeks. So in 2 weeks, please be ready to write more code. It should be a lot of fun, and we'll be working on some more things together. We're going to build on what we've already covered, but we're still going to be like a follow-along type structure, so even if you missed these, you can still follow along and pick up what that is and learn the rest as you go. Also keep in mind that there are videos of everything we do on here. So if you missed episode 1 or you didn't catch the whole episode 2, you can actually watch those on here. So I see that 49 people watched Saturday's episode. And Corbob, welcome as well. Thank you for following. And also, Bubs, I saw you in the channel. Hello. So these are here if you want to check those out. There's actually full videos of all of our previous streams as well. And if you are interested in checking out any of our older videos from streams, you know, months ago, etc., those aren't kept on Twitch because it only keeps them for a little while. But those are actually out on our YouTube channel. So you can head over to... does that link work? Yep, that works. The question is, does this work yet? Okay, good, that works. So I need to fix this link here. Woohoo! So I want to do command remove YouTube, and then I want to say command add. And yes, this bot that I'm using in the stream here, you'll notice that it's responding with stuff. We build this on the show normally. So what is this? YouTube. Everyone check out archives of our videos on YouTube, and then link. So this actually won't update right away because we currently have a bug in our bot. So we're actually we're running on like latest version of our bot as we're changing things on the show. So sometimes our bot gets bugs in whatever version I'm currently running. So I'm running a version that has a bug in it, so it's not actually going to update that command just yet. But when I restart it, it will be updated. So we know what the problem is, and we will fix it. And we'll track it down on stream. So it's I actually don't mind ever when we get bugs, because I'm like, oh, this is a good chance to debug and search for what the issue is and work together on that. So it's always fun. So if you do want to check any of our old stuff, it's out here. We have a whole bunch of videos out on YouTube. Whole bunch of videos on Twitch, so there's all kinds of stuff. So, trying to think if I forgot anything. I thanked everybody for following. I thanked the people that hosted us. I thanked the people that gave us bits. I talked about upcoming streams. Other things like that. Let me see if anybody said anything in chat that I missed here. Pyro, by the way, huge kudos for doing live stream tutorials. No, it's actually... I will tell you, live streaming stuff is actually a lot harder than people realize. Okay, so you added a dot at the end of the link. Oh, I did. Yeah, that's true. I did. No, only on that one. Yeah, that is a good point. I should change how that works, Ladal. That's actually not on the link. So when we actually run it, it's going to print out differently. That's just its display there. So that is a bug with how we report what it did there. I'm going to guess Manzi is how you pronounce that. I would recommend C# over C++ for most types of programming. C++ is actually a great language. I like it a lot. But what it's not good at is things like application development and web development. So if you're interested in either of those, you're better off using C#. It can also take you a lot further. Yeah, as Pyro says, depends on what you want to do. If you want to build something with a UI, I would recommend you use C# over C++. Now, if you want to do game development, there are actually... so if you're using Unity, C# can do that pretty well, but if you're using some other engines, you might need to be in C++ and various things. If you're doing low-level programming or embedded programming and things like that, C++ tends to be better. It really comes down to what you're using it for. Any given programming language really needs to be... You choose the one that matches what you're doing. So, whenever someone says, hey, what programming language should I learn? My answer always is, well, what do you want to do? And if you're not sure, I would recommend you learn a general purpose language like a C# or like a Java or something like that, where you can use it for a lot of different things. Those are good choices if you don't know specifically what you want to program. If you do know what you want to program, then we can give a specific recommendation and say, like, yeah, this is a good answer for that. Oh yeah, no, you can connect to servers, make HTTP and requests using C++. Yes, C# is an easier language for that type of code. I would recommend using C# and .NET Core. And what Pyro mentions, while he's kidding there, C++ is a more difficult language. You have to do more stuff for yourself. It doesn't do as much for you. So that it's called a lower level language, and you can get more stuff done with C# than with less code, is the idea. Yeah, and so what Sodza is pointing out is that, like, doing a basic connection on the internet, you can use C++ and it works. It's not great, but you'd be better off using C#. Is the short answer there. So anyway, and I also saw in there the question that was asked of how many episodes do I think will be in the Learn to Code in C# series. I'm not sure how many we're going to do entirely. We're certainly going to get through 6, because I had 6 episodes worth of things that I was like, yeah, those would be good ones to cover. If there are more things I want to add, or if a lot of people like it, I might keep it going longer. So we'll see. The nice thing is that I can just add new events on to the end of that series if I want. So if we decide we want to keep it going or revitalize it at some point, we can do that as well. But it's going to be at least 6, probably more. So Trekked, the list is actually going to be on the events page, but I have not updated all the events with what the topic of each one is going to be yet. So far I actually only updated episode 1, and I need to list for the next 4 episodes what those topics are, but again, as I'm sure you guys can guess, time is always a factor, so I put a lot of time into the stream, pretty much as much as I can, because I do really love what we're doing here, but I don't always get to everything that I'm trying to get to, so we'll see how that goes. And Pyro, threading and tasks and that sort of thing is probably not going to be part of our Learn to Code in C# series. If it is going to be well after episode 6. That's because that's probably a little high even to get into in episode 6. There'd be a few more episodes before we got to that one. But threading and tasks and that sort of thing is definitely something that I am planning on covering more in our regular streams. So we will be covering those there. And yes, Manzi, I do have Docker installed, including the extension, but we're not using that in the Learn to Code in C# series. Yeah, so part of the challenge there, Pyro, is if we start doing threading, that's going to get really high. That's going to get probably a little difficult for the early programmers. We're more likely to do some stuff in the Learn to Code in C# where we're having everybody build stuff using the existing knowledge they've learned from the other streams. So that's probably the route we're going to go there. Anyway, I'm going to wrap up the stream here. So I want to thank everybody for showing up and chatting. It was a lot of fun. So keep the chatter alive, and I will see you all later. And don't forget, follow all the various things, and I will catch you tomorrow. So, and we'll have Simon Timms on, and it'll be fun. So, bye everybody. Enjoy the rest of your Monday.